Hello and welcome to the Shell System Building Assembly, a practical sustainable building envelope solution, sponsored by XL Sustainable Building Systems. Learning objectives. By the end of this course, you will be able to recognize the need for energy efficiency in residential building envelopes to protect both the environment and occupants. Define the Shell System SS assembly envelopes and list their benefits, such as cost effectiveness, energy efficiency, durability, and sound control. Recall testing, codes, and green building initiatives that pertain to Shell System SS assembly envelopes. Discuss how to specify and install Shell System SS assemblies in a wide variety of residential and commercial applications. First, let's begin by discussing the need for energy efficiency in residential building envelopes to protect both the environment and occupants. Energy is required to power our day-to-day lives. Whether at work or at play, we rely on energy to use lighting, appliances, electronics, etc. However, more than half of a U.S. household's annual energy consumption is used on space heating and air conditioning. EIA, Use of Energy Explained, Energy Use in Homes. The average U.S. household consumes about 11,000 kilowatt hours per year. However, residential energy use can vary dramatically based on location and housing type. For instance, a detached single-family home in the South consumes an average of 15,819 kilowatt hours per year, while an apartment in a multifamily complex in the Northeast only consumes 4,120 kilowatt hours. What accounts for this difference? First, homes in the South are more likely to have both heating and air conditioning, and use more air conditioning during the summer than residences in other regions. Second, the average single-family detached home consumed nearly 3 times more energy than an apartment building with 5 or more apartments. EIA, Use of Energy Explained, Energy Use in Homes. How do we create the energy needed to make our spaces more comfortable? In the U.S., we primarily use natural gas and coal to generate the electricity we need. EIA, Electric Power Monthly. Natural gas and coal are fossil fuels, and unfortunately, the burning of fossil fuels is responsible for 76% of greenhouse gas emissions. EIA, Energy and the Environment Explained. These greenhouse gases cause climate change, which can be seen now in rising temperatures, glacial melting, rising sea levels, and volatile weather events. The energy crisis doesn't just affect the environment, though. It has very real effects on people as well. Researchers at Arizona State University found that, as changing temperatures may alter heating and cooling loads, residential electricity demand could increase by as much as 41 to 87% between 2020 and 2060. Reyna and Chester, 1. The World Health Organization argues that issues of thermal comfort, energy demand, and energy vulnerability are becoming potential new health threats. Thermal comfort and energy. If homes aren't properly built to handle extreme temperatures and other weather events, occupants can be exposed to indoor biological agents, which cause a wide range of health effects. According to the WHO, inadequate ventilation and structural failures, as well as problems with thermal comfort, can cause asthma and other respiratory symptoms. Protecting health from home damp and mold. Improving the energy efficiency of residences benefits both the environment and occupants. It protects the environment from climate change by reducing energy use and protects occupants from the health hazards of extreme temperature and weather. WHO, Housing, Energy, and Thermal Comfort, 1. One of the most effective ways of improving the energy efficiency of residential buildings is improving the building envelope. When not properly insulated and sealed, homes can lose as much as 40% of heating and cooling energy through cracks and gaps in the building envelope. Kosher. Building more efficient homes lowers energy use and reduces peak demand. Joule 2371. Researchers in the U.S. found that the best intervention to lower energy use and reduce peak demand in homes was improving the thermal integrity of the house. Joule 2371-2. Thermal insulation measures have positive impacts on indoor temperatures and thermal comfort and insulated dwellings. Enhance the relevance of ventilation and air exchange in order to reduce accumulation of indoor pollutants and mold growth. Braubach, Heinen, and Dame, 38. Clearly properly insulating and sealing the house with an effective building envelope is the best way to protect both the environment and occupants. But what exactly is the best method? Simply put, the building envelope is what separates the interior of a building from the exterior. It can be separated into three general categories: support, the structural elements that physically support the building; control, the material elements that control what comes in and out of the building; and finish, the design elements that aesthetically complete the building. Straub and Burnett. The control layers make or break the performance of the building, especially in terms of energy use and occupant comfort. There are 5 main control layers. Water layer controls any influx of water, especially rain and weather. Air layer controls airflow between conditioned and unconditioned spaces. Vapor layer controls movement of water by vapor diffusion. Thermal layer controls transfer of thermal energy, i.e. heat. Elsteburek, BSI-001, the perfect wall. And finally, we also have the sound control layer. Dr. Joseph Elsteburek of Building Science Corporation and the U.S. Department of Energy's Building America program describes the perfect wall as one that has the water, air, vapor, and thermal control layers on the exterior of the structure. According to Elsteburek, a clever version of this first wall is where spray-applied, closed-cell, high-density foam is used to combine the 4 principal control layers in one material. BSI-001, the perfect wall. According to Spray Foam magazine, sound waves are transmitted by vibrations that move through the air and through solid objects, like building materials. When a sound moves from one room to another, or from the outside to the inside, the sound wave has either moved through the air or through the walls, floors, and ceilings. This is from an article titled Foam and Sound: How Spray Foam Can Effectively Reduce Noise, authored by Robert Naini on February 27, 2018. Naini continues on to explain that there are 3 ways to reduce sound: blocking, absorbing, and dampening. However, they are not all the same in reducing noise. This all comes down to what type of noise is generated. He goes on to point out that sound blockers are the most important type of defense for sounds that are moving from space to space, for example, outside to inside. This can include street traffic, your neighbor's music next door, or your kid's television upstairs. Gypsum wallboard falls into this category of sound blocker, and it is one of the most used in all types of construction. They essentially help block, stop, and redirect sound waves. This material is hard and dense and lowers sound transmission. Also, closed-cell spray foam works as a sound blocker because it is an air barrier and will block airborne sound transmission. Next, we'll look at shell assembly systems, an innovative building envelope solution that is cost-effective, energy-efficient, and durable. But first, let's briefly discuss SPF. Spray polyurethane foam, or SPF, is a spray-applied plastic that can form a continuous insulated barrier on walls and roofs. SPF is made by mixing liquid components at the job site to create foam. When mixed, the liquid quickly expands on contact to create foam that insulates, seals gaps, and forms moisture and vapor barriers. Spray Foam Coalition 1. There are three primary types of SPF: high density, medium density, and low density. Medium and high density SPF are known as closed cell foam due to the internal closed cell structure. Unlike low density SPF, which has tiny holes or open cells, closed cell foam improves thermal resistance. Spray Foam Coalition 1. Because of these properties, spray polyurethane foam has long been used as insulation. SPF helps stop air leaks in the building envelope, which can help reduce a home's energy consumption and lower greenhouse gas emissions and consumers' utility bills. Caution: it also has sound deadening capabilities by blocking air leakage and by joining or gluing the building components together to reduce overall building noise. SPF insulation has a much higher R value, used to measure insulating capabilities, than other insulation materials, and is better at controlling moisture as well. With that in mind, let's briefly review everything we've discussed so far. First, the building envelope is crucial to decreasing energy use and increasing occupant comfort. Next, the perfect wall concept prescribes an exterior application that combines all four control layers in one. Finally, high-density closed-cell SPF is the only material that performs all of the roles of the control layers. The innovative SPF shell assembly incorporates all of these factors into an efficient and innovative building envelope solution. It only uses 4 building components: framing, drywall, standoff, polystyrene block that adheres to the inside face of the stud or joist, and closed cell spray foam. We'll go into further detail about how to install the SS later, but let's go over the basics. After framing is in place, 1 to 1.5 inches of spray polyurethane foam is applied during drywall installation to lock the drywall in place and waterproof it. Next, utilities are installed from the exterior. Then, spray foam is applied again to encapsulate everything together. Finally, cladding is installed and the project can be finalized. No exterior sheathing is needed. Shear strength is accomplished by bonding the 4 components together. The SPF shell system assembly has many benefits. First, it's faster and less costly than traditional building envelopes. Because it serves the purpose of 4 control layers in one, it decreases construction costs and building schedules. Interior and exterior finish work can be done concurrently. Second, no new material or systems are needed, as the system utilizes standard construction methods and materials. Third, it has better overall wind resistance than mechanical reinforcing systems, making it ideal for rebuilding after disasters such as tornadoes. Fourth, the continuous SPF insulation layer virtually eliminates thermal breaks and bridging and provides a complete drainage and drying plane at the exterior facing surface of the assembly. Finally, the shell system also reduces heating and cooling costs by improving the building's energy efficiency, providing a path toward true net zero performance, and is the best single-layer sound control available in the market today. As you can see from this chart, Utilizing CCSPF in the shell assembly system benefits many aspects of the design process: design, construction, code compliance, and sustainability. Characteristics of CCSPF, such as air impermeability, expansion, adhesion, insulation, and water impermeability, are advantageous to any project. Now, let's discuss important testing, codes, and green building initiatives that pertain to shell systems. In 2005, Oak Ridge National Laboratory tested the R values of loose-fill fiberglass, as well as low-density and medium-density spray polyurethane foam, SPF, insulations. They found that the SPF systems significantly outperformed the loose-fill fiberglass, maintaining 74% and 83% of labeled R value during cold conditions, compared to 46% for the fiberglass system. During hot conditions, SPF systems maintain 61% and 67% of labeled R value compared to 51% for the fiberglass system. Quoted in BD+C Energy Performance 6. CCSPF is also considered an acceptable flood-resistant material by FEMA because of its ability to be exposed to water for significant periods of time without sustaining damage. With the foam shell system, approximately 2.5 inches of high-density, 2 pounds per cubed foot polyurethane foam is sprayed from the outside of the wall against the internal sheetrock walls and between the wood 2x4 studs. After the foam hardens, it has significant strength, stiffness, and cohesive strength, essentially gluing the sheetrock to the wood studs and forming a structural system with high stiffness and strength. Gerstle 1. Testing performed by a professional engineer showed that the foam shell system is as strong and stiff as a traditional OSB stud shear panel in terms of both racking capacity and load-bearing capacity. Gerstle 12. The graph on this slide represents the data obtained from the lab results. As can be seen, the SS test material outperformed all other samples, including the traditional shear panel, OSB, screwed to framing section. Each test was performed over a period of about 10 minutes. The racking strength of the panels used the revised test configuration, shown in Figure B, was much higher than in the previous suite of tests, shown in Figure A. Look for shell assembly systems that use CCSPF that meets important standards and codes. According to the International Building Code, IBC 2603.4, and the International Residential Code, IRC R316.4, all foam plastic insulation must be separated from the interior of the building by an approved 15-minute thermal ignition barrier, such as half-inch gypsum wallboard or equivalent material. However, materials that pass Appendix X are approved for use as a code-compliant alternative assembly without an ignition barrier. Using the shell assembly system with CCSPF provides a dependable method to build homes that achieve the standards of many high-performance home programs, including the EPA's Energy Star for New Homes program and the U.S. Green Building Council's USGBC LEED for Homes program. BD+C Energy Performance 1. Since 1992, the U.S. Environmental Protection Agency has operated the Energy Star program, which provides builders and homeowners a way to save energy, save money, and protect the environment. Energy Star's Certified Homes program recognizes new homes that have the best, tried and true, integrated construction practices, resulting in better quality and durability, better comfort, better systems, a better value for today, and a better investment for tomorrow. EPA, a complete thermal enclosure system. Residential new construction projects must meet strict program requirements focusing on thermal enclosure, heating and cooling, water management, and lighting and appliances. ENERGY STAR certified homes and apartments are at least 10% more efficient than homes built to code. EPA about the ENERGY STAR residential new construction program. The shell assembly system, by utilizing closed cell SPF, can help builders apply for ENERGY STAR's Certified Homes program, as it creates an overall air barrier and thermal barrier alignment, an efficient method to insulate walls adjoining exterior walls and unconditioned spaces, and an insulation installation that maintains permanent contact with the stem walls and subfloor above and ceiling cavities. The shell assembly system also fully seals shafts such as duct, piping, and flue shafts, attic and ceiling penetrations, and common walls between units. BD+C, Energy Performance 8-9. The shell system assembly can also help projects apply to green building rating systems, which encourage sustainable building design. Leadership in Energy and Environmental Design, or LEED, is the most widely used green building rating system in the world. Available for virtually all building types, LEED provides a framework for healthy, highly efficient, and cost-saving green buildings. Projects pursuing LEED certification earn points for various green building strategies across several categories. Shell system assemblies can help projects apply for several credits in the Energy and Atmosphere category. First, the prerequisite minimum energy performance, which focuses on reducing excessive energy use by achieving a minimum level of energy efficiency for the building and its systems. Projects just need to comply with ANSI, ASHRAE, IES-NA Standard 90.1-2016 to meet this prerequisite. Next, the credit Optimize Energy Performance, which focuses on achieving energy performance levels beyond the prerequisite standard to reduce environmental and economic harms associated with excessive energy use. Projects need to analyze efficiency measures during the design process, use energy simulation of efficiency opportunities, analyze efficiency measures, and project potential energy savings and cost implications to earn points for this credit. In the Indoor Environmental Quality category, shell system assemblies are relevant to 2 credits. First, the Low Emitting Materials credit. This credit focuses on reducing concentrations of chemical contaminants that can damage air quality, human health, productivity, and the environment, such as volatile organic compounds, or VOCs. By choosing spray polyurethane foam that meets emissions and content requirements, project teams can apply for this credit and ensure the safety of both installers and occupants. Second, the Thermal Comfort credit, which focuses on occupants' productivity, comfort, and well-being by providing quality thermal comfort. Projects can address this credit by designing the building envelope, such as the foam shell assembly, to meet the requirements of ASHRAE Standard 55-2017, Thermal Comfort Conditions for Human Occupancy. While LEED certification focuses on a project's impact on the environment, the WELL building standard is another building rating system that encourages architecture and design that promotes human health and wellness. Created by the International WELL Building Institute, the WELL building standard considers a building's effects on the whole human body and the ability of a facility to holistically support wellness. Projects pursuing the WELL building certification earn points for various clean building strategies across several standards. Shell systems can help projects apply to several features in the AIR standard. First, The VOC reduction feature focuses on minimizing the effect of VOCs in building materials on indoor air quality. Utilizing CC-SPF insulation that meets the California Department of Public Health CDPH Standard Method version 1.1-2010 or later in the shell system, projects can apply for points. Next, projects can seek points from the moisture management features by detailing how the shell system will address liquid water from both exterior and interior sources, such as building penetrations and plumbing. Shell system assemblies can also help projects earn points for air infiltration management if the project team performs envelope commissioning in accordance with ASHRAE Guideline 0/2005 and the National Institute of Building Sciences NIBS Guideline 3/2012 for new construction or structural renovation. Finally, projects can receive points for the humidity control feature, which entails either including a ventilation system that maintains RH between 30 to 50% or modeling humidity levels that are within 30 to 50%. Shell assembly systems can also help projects apply to one feature in the comfort standard. The thermal comfort feature focuses on balancing the energy requirements of the building with occupant comfort. For credit, all occupiable spaces in mechanically conditioned projects, including circulation areas, must meet ASHRAE Standard 55, 2013, Section 5.3, Standard Comfort Zone Compliance, which determines temperature limits that prioritize occupant thermal comfort. Finally, to protect the health of both installers and occupants, ensure that the CC-SPF that is used in any shell assembly system meets the highest Green Guard standard, Gold. The Environmental Protection Agency warns that volatile organic compounds, or VOCs, that are present in many building materials can negatively affect indoor air quality and our respiratory health. To reduce indoor air pollution and exposure to toxic chemicals, look for products that are UL Green Guard certified, which means they have been thoroughly tested and meet VOC emission limits. Green Guard Gold certification has even stricter requirements, ensuring products with this label are safe for even at-risk environments such as healthcare facilities. Finally, let's discuss how to specify and install shell systems in a wide variety of residential and commercial applications. Spec writers should focus on specifying the four components that go into the shell system: framing, drywall, standoff, and CC-SPF. To reiterate an earlier point, the materials used in the shell system aren't new. All that is entailed is rearranging the sequence and manner in which these materials are installed. Thus, the specification focuses on a new sequence, not new materials. Specifiers and other professionals should discuss shell assembly projects with local code officials and make adjustments as necessary. The installation process is overall similar to traditional methods in terms of planning, approvals, etc. First, brace the framing or shear panels, plywood nailed to the outside of the studwork where needed, to fulfill code requirements and keep the walls from bucking, moving sideways in the wind, etc. Get the framing up and keep it plumb. At this point, traditionally, a framing inspection would be done once outside sheathing is up. Although there is no outside sheathing with the shell system, projects that have worked with local code officials from the beginning should be able to still pass inspection. Next, install drywall. Always install the lids, i.e. sealing, first. Install HD polystyrene standoffs to the inside face of the studs that are part of the envelope walls and ceilings. Then, spray a layer of foam to fill the gaps between the studs and drywall, which also stabilizes the drywall so it can't move. This is sprayed from the outside. the main difference between how spray foam is usually installed in the shell system. This creates a rigid, durable, weatherproof layer and allows removal of any exterior sheathing that was installed to stabilize the structure. Then, other trades can come in and do their work, including plumbing, electrical, other utilities, etc. Temporary penetrations can be sealed with foam-in-a-can products. Next, another layer of foam is applied from the outside to encapsulate everything, which provides an extremely high level of insulation. Finally, cladding is applied and the building envelope can be finalized. SPF insulation could pose a potential hazard, so it is essential that SPF installers and SPF component suppliers work towards ensuring that every SPF installation is done properly and with the utmost consideration for health and safety, both on the job site and the surrounding area. Spray Foam Coalition 3. Additionally, foam is easy to cut with a sharp knife, so maintenance or repairs will be very easy. You can drill through foam, then seal it with a foam repair kit provided by the manufacturer. Shell system assemblies are good for all applications: residential, commercial, multi-story, anything that uses framing. Even high-rise buildings could potentially use the shell system assembly, where framing is used to block out interior areas. The open stud and frame construction used in shell assemblies easily allows for smart home capabilities to be integrated into the residences from the beginning. Because of the shell system's increased thermal efficiency, HVAC needs might be low enough to go off-grid if combined with renewable solar and/or wind and passive systems. We'll conclude this course by summarizing the main points and reviewing the learning objectives. First, we learned that the building envelope is crucial to decreasing energy use and increasing occupant comfort. Then, we explored the perfect wall concept, which prescribes an exterior application that combines all four control layers into one. Next, we examined spray polyurethane foam, particularly how high-density closed-cell SPF is the only material that performs all of the roles of the control layers. Finally, we considered the innovative shell system utilizing CC-SPF, a practical, sustainable, and cost-effective building envelope solution that has a practically endless variety of applications. Now, you will be able to recognize the need for energy efficiency in residential building envelopes to protect both the environment and occupants. Define shell system SS assembly envelopes and list their benefits, such as cost effectiveness, energy efficiency, and durability. Recall testing, codes, and green building initiatives that pertain to shell system SS assembly envelopes. Discuss how to specify and install shell system SS assemblies in a wide variety of residential and commercial applications. Thank you for participating in Foam Shell Assembly Systems, a practical, sustainable building envelope solution, sponsored by XL Sustainable Building Systems.